Hello all and welcome to this Agentic AI course. So in this course, we will master Agentic AI from complete beginning to the production level project. So in this tutorial or in this series, we can say we will cover complete Agentic AI. And if you talk about this particular video is going to be the introduction video for Agentic AI. So in this video, we will understand what Agentic AI is, why we should use agentic AI, where we should use agentic AI systems, and what are the key features of agentic AI systems. Also, we will focus on the difference between multiple AI technologies. Like we will start from the very beginning. Like initially there was a rule-based systems, then there was machine learning, then deep learning, then generative AI, and now AI agents, or we can say agentic AI. We will compare everything. We will start from very beginning so that it will be easy for you to understand the journey, and at the end you will understand why we should learn agentic AI and why agentic AI is one of the most powerful technology today which can solve so many complex business problems which were not possible to solve by using some other technologies. So we will start with very basic, and then at the end we'll reach to the agentic AI, and then from the next video we'll completely focusing on only agentic AI topics, theory as well as practicals. So we will start with the first AI technology, which is machine learning. Before machine learning, most of the systems, most of the programs, or most of the softwares were created by using explicit rules like common if else statement. For each action, we need to write code. We can talk. We can talk about the rule base also. Like rule based system is for every action you have to set up the rules. Suppose you have to find. Let's take an example. Suppose we are creating an industrial robot, or we are creating a program for industrial robot. So for each action of that robot, we have to write each and every rules, and this robot will not act just outside of that rules or those rules. So after that, there comes a term called as machine learning. So we will start with machine learning first, and we will not dive deep into each and every technology, but we will take a overview of each technology so that it will be easy for you to understand how evolution or how the progress of AI happens. So we will not talk about a rule based system here, but the first term we have to understand is machine learning here. So let me add heading machine learning. Okay, so machine learning is simply it solve the problem of adding manual rules. It solved the problem of adding manual rules. So the flow of machine learning was, so we'll not write all the definitions and everything, but we'll understand how these things actually work. Okay. So machine learning is nothing. In short, I will add the definition here. Short definition: branch of artificial intelligence which train on data and predict future event on the basis of past data. So this is simple definition. This definition might, the definition which is present on internet or Wikipedia might be different, but this is the simple definition we can use to understand the core idea of machine learning. So machine learning is simply the branch of AI where we can add where systems train on data, or can say the input data, and predict future event on the basis of past data. Here we can add the term without explicit programming. That's it. This is the simple definition of machine learning. So machine learning is nothing but here in if you talk about the diagram, if you create the diagram here, so the simple diagram could be first block is your input data, another block will be your learning, and this block will be your out. That's it. So here I will add input data. So here, then here learning, For learning, we can have multiple algorithms in machine learning, and here your prediction. For prediction, we can say output of this system. Okay, that's it. So, here, uh, first is your input data. We send this input data to your algorithm. Then your algorithm learn and find the patterns, or in simple, the rules present in that data. Your algorithm detect the rules which are present inside that data, and on the basis of that learn rules, your model is able to predict the future event when we give new data. This is the core idea of machine learning. Then there are some types of machine learning like supervised machine learning, unsupervised machine learning, reinforcement learning. Yeah, these are the three main types of machine learning, and machine learning is nothing but the branch of AI which is work on input data, find the rules present of that input data, and then on the basis of that rules which are learned during the training process, the model is able to predict the future event for the new data points. That's it. This is machine learning. Okay, we will go step by step. Like machine learning was there, machine learning is still used in this industry, and so many business problems are still solved or can be solved by using machine learning. But still there are some limitations of machine learning, and just to solve that machine learning limitations, new technology comes to the picture. So machine learning was the first system officially, mostly which is used in industry. Then there are some limitations of machine learning, and on the basis or in order to solve those limitations, new term or new advanced technology comes to the market. We will understand this technology also, but in in simple term, we are learning agentic AI, but we will start from the very beginning, like from machine learning to deep learning to generative AI, and at the end we'll see agentic AI, because so we can differentiate between those technologies. And at the end, in order to solve the program any problem or any data related problem in industry, and if we have to solve this problem by using AI, it's not compulsory to use directly agentic AI or generating AI type of model. Still we have to use some basic models also. Okay, but this series is all about agentic AI, so that we will just summarize the past technologies. Okay, so the first part is machine learning, and machine learning is the system where we provide the input data, system learn and then predict the future event. To talk about some examples of machine learning or the use cases, we can say. So in that case, if we talk about the use cases, uh, let me add the heading here. So use cases of machine learning can be uh, like any prediction of any continuous value. Let's say the simple, we can say stocks price prediction. Stock price prediction is the simplest example we can say, and this can be solved by using machine learning. We can easily predict the stocks prices of the future stocks prices by using machine learning on the basis of past data, because we train the system on the past data. Then spam mail detection, like, okay, detection of mail, whether it's a spam or not spam. This is also the well-known example of machine learning. So this is all about machine learning. So in a nutshell, if it say machine learning is simply the branch of artificial intelligence, which has some algorithms. In machine learning there are so many algorithms, like for some algorithms are it comes into supervised category, some algorithms comes into unsupervised category, and the main idea is to learn the pattern or the rules from the past data, and on the basis of those rules just predict the future event. That's the main idea. Now if you talk about use cases, so use cases are stocks price prediction. We can predict the stocks price for future by using machine learning. Then spam mail detection, whether your mail is spam or not spam. This is kind of classification problem, and classification is also the branch of machine learning. In supervised there are two branches, classification and regression. So here I will just for a reference I will add. You can explore. These are very simple concepts. So stock price prediction is the example of regression. Regression means predicting continuous value. So your output will be any value between a particular range, like stocks price or house price prediction, we can say. And spam email is the example of classification. Okay, just a minute. Okay, just a minute. So this was the example of classification. So classification is simply classifying your event or data point into multiple classes. So in that case, your mail can be spam or not spam. Now, this is your machine learning. Okay. So we are summarizing the machine learning in simple case. It's also the branch of AI. Then let's talk about the limitation of machine learning. Okay. So if you talk about the limitation of machine learning, then again, it's a most important part because there are some limitations. First is manual feature selection. So I will explain that part. Like, let's say I have to predict the house price or stocks price. So for stocks price prediction, I have to consider multiple factors, like which factors are responsible to predict this stock or stocks price. This part is completely depend, or this part was completely manual, or still this part is manual in machine learning use cases. And that's the reason that your accuracy might be affected as compared to person, because this is, yeah, there are some techniques available which we can use, but still it can give you different result if we tune it differently. So this is the limitation of machine learning, like manual feature selection. Manual features in the sense the factors which are responsible to predict the stocks prices. In that example, also the factors which are responsible to consider even a single mail as mail or sorry, a spam or a not spam. So this kind of features or this kind of properties are very important to understand, and this is little manual in machine learning. Also, we can say data size is also a problem. Most of the machine learning algorithm were not good when data size increases. So data size limitation is also there. So there are still, if you discuss, there are so many points are there with respect to the limitation of machine learning. But still, machine learning has some plus point also, some pros also, some cons also. Still, we can use machine learning when we have a proper data which is whose distribution is very constant. When data is not complex, the variation of data is limited. When data size is limited, in that case, we can still use machine learning. Now, next part we have to discuss is deep learning. So these limitations are solved in deep learning. So our next part we have to discuss here is deep learning. So let me add the heading here. Okay. So deep learning again, it's a branch of or subfield of machine learning. Subfield of machine learning, which uses neural network in training process. Okay. So and same just like machine learning, it's also train on past data and predict the future event. The only difference in deep learning was it uses neural network. Initially our machine learning were using the statistical models or algorithms, but here we use neural network. What is neural network? Neural network is a robust combination of multiple neurons, which are the mathematical systems. In the backend they use on mathematical formulas, and they are highly capable of understanding the rules from the data or finding the pattern from the data. And also, you don't need to perform manual feature selection. Neural networks are capable of analyzing the important factors or important feature which are necessary to predict the output. Okay. If you talk about neural network, then this is also the big topic. If you have to understand the architecture of neural network, this is very big topic. We need to dive deep into it to understand what is neural network. Then there are multiple layers in the neural network, like input layer, output layer. But in simple, if you talk about just like here we discuss machine learning, in simple we will understand the architecture of neural network, but in very simple way. So let me add layers. This is my one layer. This is second layer, and this is my third layer. Okay. And my input data will feed here. Okay. Input data will be there. And one more thing we have to add here, which is neurons. So inside layer, there are some neurons like that. Okay. So might be the neurons, the diagrams will not be so consistent, but we have to understand the topic only. And the number of neurons in the output layer will depends upon the nature of output we want. Okay. So here, and let's say in simple, one neuron from this layer will be connected with all the neuron of another layer, just like that. This is the simple architecture of neural network. Then this neuron will aggregate the result at this output layer neuron. That's it. This is simple. Now, if you have to mention name of each layer, then the first layer is your input layer. This is your input layer. Then this is your hidden layer. This is the hidden layer. And the last one is your, sorry, yeah, output layer. Okay. This is your output layer. Okay. So this is the simple architecture of any neural network. So in neural network, mostly we have input layer where we feed our input data. Input data means the data which we are using to train the system. Then we have hidden layer. Hidden layer is nothing but the brain of your neural network. And just keep in mind, hidden layer is not single. There can be a single input layer. There can be a single output layer. But there are multiple hidden layers are there, as big as your as long as much as your hidden layer, as better as your learning, we can say, because this is the brain. The actual learning, actual adjustment of your weight is happen in the hidden layer. So this is the specialty of deep learning. So deep learning algorithms are capable of handling more data as well as capable of finding more complex rules from the data as compared to machine learning. So this is deep learning. Also, in deep learning, we can process text data, we can process image data, we can process audio data also. This was also, or this is also the important benefit of using deep learning. So this is all about deep learning. So let's discuss what use cases or what problems or what projects can be solved by using deep learning. So let's talk about the simple use cases. So, use cases are like, let me increase the font size for better visualization. Use cases are like image classification. Then sentiment analysis. These are the two important use cases can be solved by using deep learning. Okay, and also one more thing, this is not possible by using your machine learning. Okay, image classification. Sentiment analysis. Yeah, we can perform some sort of sentiment analysis in machine learning algorithms also, but basically, we can do very good for this kind of task. Also, fields of deep learning, which mostly mention these use cases, are for image classification. We called it as computer vision. And if in deep learning, if you are working with text data, we called it as natural language processing, or in short NLP. And then again, this NLP and computer vision are penetrate more, progress more, and then come up with the next evolution or the next progress called as generative AI and all. We'll discuss about it. So here, if we talk about deep learning, so again, deep learning is the subfield of machine learning which uses neural network in training process. Okay, and what is the main problem which this neural network solve? The manual feature selection was solved and amount of data handling. So machine learning algorithms were saturated, mostly saturated. If we continuously increase the data size. But deep learning algorithms are data hungry. We can use huge amount of data to load in those algorithm in neural network. Okay, neural network are, we can say, the backbone of modern AI history or modern AI evolution. Okay, and the simple structure of neural networks is like input layer where we feed our input data, then hidden layer where actual learning happens, and output layer where we get our final results from the algorithm. Now let's talk about the limitation. So So if we talk about the limitation, so the only thing which need to be improved is single or individual model. Individual model for individual use case or individual problem statement. Okay, so if you build one model or if you build any project around NLP, then this project cannot solve the problem of computer vision. So deep learning algorithms were specific about the use cases. So the algorithms used for NLP are different. The algorithm used for computer visions are different. So this is not a deep dive into deep learning, or these branches are very huge. There are so many things to study. We are just understanding the flow, like how we are moving towards the agentic AI. So deep learning, in deep learning we use neural network, and in deep learning there are individual models. Like for sentiment analysis we have different model, for image classification we have different model. Now after that, the real progress happens in the field of generative AI. Okay, so here after deep learning, the new terms comes to the market called as generative AI. Okay, so here generative AI. Now, in as the word suggests, at the heart of generative AI, the word is generate. What is generate? Generate means creating something new. So generative AI is nothing but generating new content, or generating directly new data on the basis of data which is used for training those models. And from generative AI, we got the most evolutionary term called as LLM, large language model. So, generative AI is all about creating new content, and the models which are used or which are built around generative AI are called as large language models. So if you talk about the definition here, let's add a simple definition. AI system which can generate new content, okay, which can generate new content. So these are the system which are trained on huge amount of data. So basically, instead of training single model for each use cases, let's say for sentiment analysis, for image classification, companies have used huge amount of data, which is mostly available on internet, and use this data to train a single model. We can call it as foundational model. So companies have built foundational model. So I will add the definition: foundational model. Okay, so if you talk about the foundational model, so it's a single model for multiple use cases. Okay, so these models are capable of solving multiple problems. So this model can solve your problem of sentiment analysis. This problem can solve your problem of image classification. Along with that, like sentiment analysis, it's kind of predictive task. Then if we talk about image classification, this is also the kind of predictive task. But these model are capable of generating new text also, new images also, and even new code also, because these foundational models are trained on huge amount of data. They have learned the distribution present in the data, and then when we required something, when we need new content, whether it's a text, whether it's an image or code, these models are capable of generating this new code also. So foundational models, or in simple case we can say large language model, we can use the word here LLM. Foundational models are nothing but LLM. We can use the word LLM. LLMs are nothing but single model for multiple use cases. This is the simple definition we can use for that. And if you talk about the use cases, so then again, it's text generation, then image generation, code generation. Okay, so these are the some basic use cases, but along with that, we can perform so many actions by using those foundational models, or by using in simple, by using generative AI. So this is all about the generative AI. And if you talk about the examples, so many chatbots are available in the market. Some famous examples are ChatGPT from OpenAI. OpenAI has trained their foundational model like the GPT models, and they launched a product called as ChatGPT. ChatGPT uh, is a chatbot we can use to create images, to create or to generate text, to generate code also. Then along with ChatGPT, there are so many products are available in the market which are works on that, on those foundational models. And even if we have to use those multiple models, we can also use by using the API key. Those companies have provide API key, and by using this API key, we can also use those models, because these models require huge computational power, and individual person may or may not have such kind of computational power. So by using the API, we can use those models. So this is all about generative AI. Now let's talk about the limitation, because generative AI is one of the most, we can say one of the robust technology in AI era, but still it has some sort of limitation. We cannot say it's a limitation, but yeah, some kind of issue which is associated with generative AI or LLMs or chatbots. Okay, so now let's talk about the limitation. So limitations are: chatbots are reactive. Okay, chatbots are reactive means it only answer when we ask something. Like like let's say we have to ask, like, what is the current weather in my city, or you can mention your city name, then it will return the current weather. If you ask what is the distance between sun and earth, then it will return you the answer. So it reacts when we ask something. So your chatbots or the generative AI systems or the system which are built on the basis of generative AI, which are these systems are reactive system. They will not autonomous systems. So here chatbots are reactive, not autonomous. Yeah, chatbots are autonomous also, but when we add agentic capabilities into it. Okay, but currently we are understanding generative AI. So the LLMs which are not agentic or the chatbots which are not agentic are only reactive chatbots. So when we ask question, they will give answer. They will not do anything apart from this. So let's say when we add create an image of a person riding a horse, so it will create an image, nothing. But these are the limitations with respect to LLM or chatbot, and this is the limitation can be solved by using agentic AI. So the next term, which is the most important term for this or for this video, as we have started, the heading of our video was agentic AI. But we summarize machine learning, we summarize deep learning, we summarize generative AI. Now let's move to the main part, which is agentic AI. One of the most trending technology and one of the most powerful technology nowadays, which is agentic AI. Okay, so we'll dive deep into agentic AI now because now we are good with the foundation of AI, like what is machine learning, what is deep learning, what is generative AI, and what are the limitations. Now let's discuss what is agentic AI. Let's discuss agentic AI with a very simple definition. So let me add the definition here. So I will use the most or can say the very simple definition so that it will be easy for everyone to understand. So agentic AI is nothing but the AI system. Okay, let me increase the font size here. The AI system which can solve complex problems. Okay, the AI system which can solve complex problems. I will highlight this word, then I will explain why I have highlighted this. The AI system which can solve complex problem with limited supervision. Okay, so there can be a multiple definition of capture the main essence of this technology. This is the simple definition we can use. Okay, so here two important words are there. One is complex. Okay, we can solve complex problems or the complex industry problems by using agentic AI with limited supervision from the user. Means so limit supervision. So new word comes here called as autonomous. So agentic AI systems are autonomous system which can perform their task on own. Okay, so we can perform some actions on their own. These systems or this program can perform their actions. Okay, and complex means the tasks which are not linear, which are not uh, easy to solve directly with a series chain. We'll explain all this. We'll understand all these topics later. But now let's understand what is agentic AI in very simple way. Suppose agentic AI is limited supervision, so you don't need to perform all actions. System will take actions, will perform actions, will take decision on its own. This is what we call as agentic AI system. So agentic AI system consists of AI agents. Agentic AI systems consist of AI agents. Okay, so AI agent is also the most important term here. Okay, so let's say, what is AI agent? Okay. So let me define AI agent in very simple manner so that it will be easy for you to understand. Now, let's understand what AI agents are. Okay. So let me add again one simple definition. So AI agent, the definition here, the AI agent is a system. Okay. So I am considering single agent here for definition. So AI agent is a system which can autonomously perform task. Okay. By designing the workflow, or can say by designing the plan, or in bracket I will use the term workflow, by with the integration of available tools. Okay. And let's add one more term, on the behalf of use. That's the simple definition I can say, which we can use to understand AI agents. Okay, now we will break down this definition. So let me increase the font size a little more. Okay, so AI agents, and let me highlight this definition from here. Yeah, so this is our definition now. Okay, so here AI agents, and now we will explain this definition one by one. So AI agent is a system which can autonomously perform tasks. Autonomously means you don't need to perform each and every action. Okay, we will understand this with an example also. But now let's understand the definition. AI agent is nothing but the system, AI system which can autonomously perform tasks. Means your involvement in every action is not required. Okay, by designing a plan or workflow. Plan means whenever we have to complete any task, we have to create plan. Suppose we have to go or we have to go outside to play cricket, we have to plan, like we have to understand how much is the distance between the stadium and our home. We have to understand how is the traffic situation, what necessity is required, like what are the equipment required to play the cricket. Not equipment like bat, ball. So this is an example, like maybe we have to play cricket at a stadium. This is the goal, but in order to achieve this goal, we have to break down this goal into multiple actions, and these actions is what we called as plan. Suppose we have to cook something. Let's say I have to cook any dish. So this is my goal, but in order to achieve that goal, I have to break down this goal into multiple subtasks. Okay, so that is what we call it planning. So your AI agents are autonomously perform tasks. This is the system which can autonomously perform tasks by designing the plan. So your AI agents are capable of planning. Okay, they are capable of planning. So here I will note down properties. So first property is autonomous. Okay. So let me increase the font size, or here also autonomous. Then another is planning and reasoning. Okay, planning and reasoning. So from where we are extracting these properties, we're extracting from this definition. Okay, so again, next is designing a plan with the integration of available tools. So your AI agent are capable of accessing available tools also. Okay, tools used. okay, on the behalf of user. Means you don't need to do everything. Your AI agent is capable of doing multiple things. It will just ask you some or it takes you permission at some steps or at some points. We will understand this part later, which is what we called as human in the loop. We'll discuss this part later. But now, on the basis of this, so your AI agents are having these properties, features. We increase the font size. Okay, that's it. Your AI agent features are: first is autonomous, so your involvement is not necessary in every step. Then planning and reasoning, and they can use external tools also. We'll understand this with an example so that it will be easy. Okay, so now we are starting with agentic AI. Your agentic AI is nothing but the framework or the system, we can say, which has multiple AI agents and which can solve a complex problem with limited supervision. That supervision, use the same word again, behalf of user. So your agentic AI is a system which can have multiple AI agents to interact with each other and to solve the complex problem. That's it. This is all about the agentic AI. Okay. Now we'll understand some features of agentic AI and also we'll take one examples so that it will be easy to get clear idea about this system. Okay. So next part we have to study is key features. Features of agentic AI. So let me note down all the features here. Okay. So let's discuss what are the key features of. Now, let's discuss the key features of agentic AI, or simply you can correlate those features with simple AI agent also. Okay, let's start with the very first feature, which is autonomy. We already discussed this term here. AI agents are autonomous. So once you provide a problem statement or once you give your prompt or a goal, it will not wait for you to perform each and every action. So I will add this term here. Does not wait for user to perform each and every task. Okay. It will not wait. It's autonomous. Your agentic AI systems are simply autonomous. Okay. Then next is and also the autonomy or some benefits of autonomy. These systems are fast because once you provide the problem statement, it can automatically start finding, start planning, start execution. It's fast, completely fast. Okay. Then another is tool used. Tool use means this agentic AI AI systems can integrate with external tools. Okay, it can integrate with external tools if required. Okay, and let's say we need some data from external source. Let's say our agent is planning a trip for us. Let's say we have to go outside for vacation, and we tell our chatbot, which is agentic AI chatbot, that plan a schedule for me on that on a particular date to go from this destination, this place to this place. Simple example. So in that case your agent will check weather also. Your agent will check ticket price also. So in order to check the weather, we need access of external website, which is a weather website. In order to book the ticket, we need access of a ticket booking tool also. So agent can communicate with these external systems, with those external systems by using APIs. So currently, this is our first lecture. We are just taking the introduction about this technology. At this moment, it's you can only understand external tools means the external websites or external data sources from where our agent will take the important information. So we can say our agentic AI systems can use external tools also if required. Okay, only if it's required. Then third property is planning and reasoning. So this system can break down a big task into multiple subtasks. So a big task or goal can be converted into small subtasks. So in order to convert your main task into subtasks required intelligence. So your tools use LLM for to perform this kind of action in simples. So LLM helps your agent to perform this step called as converting your big task into small subtasks. So here your agent take help from LLM. Also, uh, at some places, if required, tool agent take help from the large language models. Okay. Now, next is error handling. Okay. If let's say we have performed a plan, but the actions are not happening with respect to plan due to any issue, let's say any problem from the external tools we are using. So in that case your agent can handle the error also. Okay, okay. So agent can handle error on its own. Okay, so how he handle the error? Let's say he created one plan from A to B to C. If B is not happening, he will check for other options. So there are some other workflows are also present. So we'll discuss these workflows in the future sessions also. Okay, so agent can handle error on its own. Let me add this line at the bottom. Then memory, the most important part. Okay, the heart of AI agent, or can say the backbone of AI agent. Okay, so AI agent, the backbone of AI agent is what we call as memory. We also called it as state. This term is also called as state. Okay, it record what is happening at each state. Okay, so when we give a goal or a task to the AI agent, AI agent has convert this task into small subtasks, and they started performing these steps or the subtask one by one. So how the data is updating at each state or each step is recorded in the memory. So memory is the most important part of your agent. So let's take an example here. Suppose here is A, okay, then here is B, here is your C, here is your D, okay, here is your D, and here is your flow. Suppose after A, B, B, C, and after that there is D. So while while this execution, some data is getting changed at every position. Let's say some data is there at A. Once B is executed, this data is getting updated. After B at C, this data is again get updated. Okay. I'm not going dive deep into technical part or showing you the exact schema of state. We'll see this in the next session. But at this moment, just understand the analogy. Some kind of data is changed when each and every step get updated or get completed. So this data or this memory is what we called as state of your agent, and this is the most important part of your agent, because if memory is not there, then how your agent can understand the actual or the current state of your system. Okay, so to understand the current state, or let's say this is our let's say we have to go from A to Z, but how the agent can understand that we are at M, we are at N. He understand we are at M or N on the basis of past data which is updated, or can say the past memory which the agent have. So this is the backbone of your agentic AI system. Okay. Now last part is feedback. Okay. If something happens as as per as per not our expectation, let's say something happen which is not as per the plan, then your agent can update or can release the feedback, and on the basis of that feedback the agent can be learn and correct his steps. Okay, so these are the key features of your agentic AI system. Okay, so let's revise from the start. So first is autonomy. Okay, autonomy. Your AI agents are autonomous. They don't need your involvement in each and every step. Then a tool used, your AI agent can integrate another tool if required. Then they can convert your big task into small tasks. We call it as planning and reasoning. Then they can handle error also. If your flow is not going as per the expectation, they can change on the basis of feedback. So we add this part here. Okay, feedback. And the most important part, state of your agent, which is the memory of your AI agent. Your AI agent handle or save the memory at each step of execution, and this memory then used later to take the next actions. Okay, so these are the key features of your agentic AI system. Okay. Now we will move next with one simple example which we can use to understand the AI agent. Okay. So I have write one example here which is very simple and from our day-to-day use. So my prompt for a chatbot, which is agentic chatbot, is I want to get fitter, but I only have 30 minutes a day. Okay. So my conditions are I want to get fitter is my goal, and constraint is 30 minutes a day. So I have my goal to get fitter, and constraint means the rule. The condition is I only have 30 minutes a day. Okay. So how your agent will work for this achieving for completing this goal? It will create a personalized workout plan by using this constraint. Okay, on the basis of this constraint that we only have 30 minutes, so on the basis of that we'll create a workout plan. So this task can be done by by using your normal chatbot also. Okay, then schedule a reminder in your calendar. Okay, so it will access the calendar app from your phone, and it will schedule a reminder. You need to go access of your calendar API to your chatbot. Okay, track your progress with your smartwatch. It will track your progress from your smartwatch by using your application, the smartwatch application in your mobile phone. Okay, and then adapt the plan if you miss a day or if your heart rate show fatigue. So maybe we plan for 30 days or we plan for 2 months, but maybe sometime it happens that we not move with our plan. So in that case your agent should be adaptive. Let's say we plan 30 minutes a day for 90 days. Okay, and let's say we are not feeling well for 1 week, then in that case your agent should adapt the available days, should manage the remaining schedule or the remaining workouts on the basis of what happen, what changes happen. This is what we call as error handling. Okay, we just understand these key features of agentic AI, and these are the feature which convert your normal chatbot into agentic chatbot. In simple case, this is the simple analogy we can use. These are the key feature which can convert your normal AI system into an agentic AI system. Okay, so this is an example, and on the basis of that we can say your agentic AI system can can be autonomous. So it can take decision on its own by taking the permission from human if required. Then it can use external tools if required. Then it can plan your big task. Planning and reasoning means it can convert your big task into small subtasks. Then it can handle error. If something happen during the execution of your plan, it can adapt that change and change your complete plan accordingly. It save memory during the complete execution, so that your agent can understand from where we started, where we have to go, and where we have now. Okay. And feedback is the term related with this error handling. So this is all about the introduction for agentic AI. So let me revise from the start what we have seen or what we have studied in this lecture. So we have started with machine learning. We understand machine learning. So your machine learning is just a simple system which has algorithm which learn on input data, and then on the basis of pattern found or the rule found from that input data, your algorithm start giving your future outputs. Then we have deep learning. So deep learning use neural networks. So neural networks are very robust architectures which are which can learn the complex patterns. And nowadays, neural network are still the backbone of your LLM also. Okay. Then the problem with deep learning was individual model for individual use case or problem statement. Then we got generative AI system, where we talk about the foundational models or the LLMs, which are single model for solving multiple problem statements like text generation, image generation, code generation. But again, there was one problem with the generative AI. We cannot say it's a problem, but yeah, this is the limitation. So limitation means your chatbots are reactive. It only react when we ask something. So in that case, we required some systems which can which should be autonomous. If we say a task, the system should break down this task into small subtasks, access external tools if required, and accomplish this task. And this can be achieved by using your agentic AI system. Then we study agentic AI. Your agentic AI is nothing but the AI system which can solve complex problem with limited supervision. So this is not the technical definition, but I use this definition to understand the concept. So agentic AI are nothing but the AI system which can solve a complete complex problem with limited supervision from the user. That's it. And then in agentic AI, at the heart of agentic AI, there is AI agent. So AI agent, I have write one definition here, which is a very simple but very powerful definition. Like AI agent is a system which can autonomously perform tasks by designing the plan. So it can autonomously perform tasks on its own. Then it can plan and with the integration of available tools on the behalf of user. And on the basis of that definition, we got these features. And now here we study the key features of complete agentic AI systems like autonomy, tool used, planning and reasoning, error handling, memory, and feedback. And now here we talk or we discuss one simple example. Okay, so this is all about introduction to agentic AI. Now, in the next video, we'll understand the components of agentic AI system with a proper end-to-end example. So now it's time to conclude this video. I hope this video is useful. So just study all this part which we have taken in this video, and then we'll see the remaining part in the next video. So keep learning and keep practicing.